Okay, so here's one to start with. It's just a review. See if you can multiply this out. Get rid of the denominator problem that I have. It'll be a quadratic. Solve the quadratic. You'll probably end up with an answer with the quadratic formula because this one I don't think factors nicely when it's all done. I'm going to pause while you work on that. Okay, so just to clarify, your first step here would be to multiply by 3x plus 2, 3x plus 2, and here also. Let's multiply on each spot. All right, you take whatever the denominators were, and that's what you multiply by. That way, this cancels this, and this cancels this. There's no denominators anymore. So what's left is kind of ugly. X squared plus 2x plus 3 equals, I thought that was going to be worse, but a lot of that canceled. 3 times 5, sorry. 3 times 5 is 15 equals 7 times 2 is 21 times x is 21x, and then 21 times 2 is 42. There's so many little places to make mistakes. I don't think these are necessarily that hard. They're just so many places to screw up. Now I bring this stuff over here because my lead coefficient is positive right now, so I'd kind of like it to stay that way. So I'm going to bring, instead of bringing this over here and making that negative, I'd rather bring the other stuff over to this side. So I'd have x squared, and the 2x and the negative 21x would make negative 19x. And the negative 42 going with the 15, it's like 40 going, negative 40 going with the 13, should be 30 and 3, 27, I think. Negative 27. And it's equal to 0. And now I'm finally ready to actually start the process of solving a quadratic. B squared minus 4ac is probably the way I'm going to have to go with this. So I'm just going to write it out, and then if you had a calculator to solve this, you wouldn't have even factored it, would you? If you had a calculator to solve this, what would you do? You graph, yep, graph this side, graph that side, see where they cross. When I graph the one, it's a quadratic, and the other, it's 0, and so it's like that. And then where do they cross? Here and here, and you find your answers. All right. Now, if it's solved algebraically, the numbers would be nicer, and you'd use quadratic form. All right, that's kind of just the big picture, what we've been doing so far. What do I have to teach you that's new? It's really not too much. There's just a couple of word problems that you have to understand. And the word problems types is one that's really important that you learn, and it's the mixture formula. You've learned a lot of formulas in your time, and this is one more that's, in certain situations, saves the day. You can come up on the ACT, the SAT, the MCA test, it's a state test you have to pass. And then there's the your tests in like chemistry and stuff, because this is mixtures, and it's really handy for science classes where you have to mix things. I'm going to pause for just a second here. So, back with you. The mixture formula, this is big. You want to write this one down. It is not going to be given to you on the test. In other words, you have to memorize it. It will be handy to know. Okay, A1, A sub 1, that means amount 1, times percent 1. Wrote that percent very small, I didn't mean to. Amount 1 times percent 1. Plus amount 2 times, take a wild guess, percent 2 will equal parentheses. And just think about it. If you had amount 1 and amount 2, how much are you going to have at the end? No, don't call it amount 3, because you can actually not have to have a whole nother variable. Nope. Amount 1 plus amount 2, yes. And then, think about it now. The other two were multiplied by a percent. This one has to be multiplied by a percent too. We just call this the total percent. All right, let me show you how you would use it. You seriously got to write this sucker down. Put a star by it in your notes or something. This is your ticket to an easy point if you know the formula. I'll show you how to use it next, but I'll show you how to use it in just a sec. That last thing says tot percent. Total percent. All right, so here's a typical scenario. Let's say that you have got some pop that is at 100% strength. Do you know whenever you add ice cubes to your pop, you're watering your pop down? You ever thought about that? It waters down a little bit because the ice cubes melt, right? So your ice cubes aren't at 100% anymore, or your pop isn't at 100% anymore whenever you put in ice, right? So they should actually be pushing, the restaurants and stuff should be pushing lots of ice, right? It's just a small little thing, but they wouldn't have to sell you as much pop because they're making you drink a lot of water. Anyway, maybe you never noticed that. So amount one, let's say that we're talking about, we have some pop that's already been watered down a little bit. So let's say we have 5 ounces of 98% pop. Now, if I add, you are a crazy scientist type, and you're like, my pop is tasting a little too watery. I can tell. I really like it at 99%, but my pop has been watered down to 98%, and that's just too much. I probably could have used like 80 and moved it up to 90 and be more believable. But do you get that I could add pure pop to it, and it will increase what percent my pop is? If I add in more like pop right out of the can, then it's going to make it more a higher percentage pop. So I add an amount, and I don't know how much to add though of pure pop. So what do you think I should put for my amount 2? Times, and then what am I putting in? What percent is this? 100% pop. Now, am I put 0.10? No, that'd be dumb. That'd be 10%. Times 1. I'll just put 1.00 just to make a point, but times it by 1 obviously really doesn't do much, but that's what it is, 100% pop. Is equal to, and then how do I finish this thing here? 5 plus x. And what's my total percent that I said I wanted it to be at the end? 99% pop. Now think about it. You could never make it 100% pop. Once it's gotten watered down a little bit, you could get it really close. You can maybe even get it to round to 100% pop. But once it's been watered down, you can't make it pure anymore. Because you can't add enough 100% pop to make that work. All right. There is how you set it up. And once you got it set up, it's easy. It's just multiply it all out and solve it. And it ends up being, surprisingly enough, a quadratic. Maybe it won't even be a quadratic. Maybe this one won't. Because I don't think this one actually will be a quadratic. But you will end up with, potentially, word problems that end up as quadratics. And then you just got to know that you can either factor them or use quadratic formula. But this one I don't think is even quadratic. All right, it'd be handy to have a calculator on this just because I use nasty numbers. But we can just kind of fake it. This is about 4.9 or something like that. It's 5 times 0.98. It's going to make it a little smaller than 5, right? Plus 1 times x is just x equals, and I'm going to multiply this out. Do you get that 0.99 would pretty much round to 1? So this would be 5 times 0.99 is even closer. That's like 4.99. And plus 0.99x. And now I'm going to subtract. I got variables on both sides. I'm going to get rid of the smaller one. What's smaller, 1 or 0.99? 0.99. So I'm going to subtract 0.99 from both sides. Subtract 0.99x. I'd end up with 4.9. And then this is I'm subtracting now. So it's 1 minus 0.99. Line through this. And then I'd have 0.01x equals 4.99. And now I'm getting closer. Is x alone yet? Nope. Just get that over to the other side. So you're going to subtract 4.9 from both sides. And I have 0.01x is equal to 0.09. And then I'm going to divide by 0.01 on both sides. And x is equal to 0.09 divided by 0.01 would be 9. So, what does that mean? That means I'd have to put in 9 ounces to make this, 9 ounces of pure pop. All right, the moral of the story is if you know this formula, you can solve any problems like this. Okay, I'll try to prove that to you. I want you to get on another, like draw a line across or something and write the formula out again. It'll help you to memorize it. Starts with amount 1. And then underneath that, I'm going to have you see if you can fill in this word problem. Again, I'll try to make it somewhat real worldish so you can see how you could actually use this. All right. Do you get that we have some uses for acid in our lives? Like actual real, like it's actually useful? Doesn't just used to hurt people? There are some times that the acid is handy. But if the acid is too strong, you obviously could hurt yourself pretty badly. If you were to take a Coke and you pour it in a glass and you drop in a tooth, like a human tooth, one of your teeth, you pulled it out and you dropped it in the glass, it would, even though if you just like left it on the counter, it would stay solid and hard like forever. Okay, it's like rock. If you put it in Coke, it'll actually dissolve. You know why? It's acidic. Is there something special about Coke? Nope. Mountain Dew would dissolve in Mountain Dew too. It just dissolves in Diet Pops. Would that help? Nope. Because they're acidic too. In fact, Diet Pops are even more acidic than regular Pops are. Okay, so just think about that. Something that you put in your mouth, drink some pop, it actually, if you left it in your mouth long enough, your teeth would all erode to be gone. If somebody forced you to keep pop in your mouth for a long period of time, it would rot all of your teeth so they would disappear. Isn't that disgusting? So anyway, nobody does that, of course. But if you're constantly exposing your teeth to pop, you think that's good for your teeth? Of course not. That's why the dentists say that it's bad for you, because bottom line is it will make your teeth disappear if you left it on there long enough. So acids are kind of scary things, but you drink them all the time if you're drinking pop. It's just that they're not very strong acids. All right, so let's talk about an acid question. Let's say that you had something that was 24% acid, and you had 8 ounces. I'm already starting to put it in the formula here for you, but I'm going to just say the rest of the problem for you. So you got 8 ounces of 24% acid. And your friend has got some pop that's more acidic, and it's 38% acid. Also 8 ounces of that. 8 ounces of, what percent did they say? 38%. That is a cool idea, but I'd rather have you do this right now. Look that up after. Then what would we be getting? What are we figuring out? The total that you'd have. If you mix these two pops together, you'd have, well, the first part is how many ounces? That'd be easy. How many ounces would you have? 16, because you had 8, and you added 8. Okay, but the harder part would be, what percent would it be at? All right, so here's how you set it up. 8 ounces of 24 plus another 8 ounces of 38% acid would equal the total, which would be 16 times total percent. And that's the one thing I don't know, is total percent. So what do I put for that? X. And then I solve for X. So this one I would want you to have a calculator. If you haven't got one yet, come up and borrow one. You'll need one for today's homework anyway. We have 2 up here just waiting for owners. Come and adopt a calculator. There's no charge. They've already been dewormed. They've been tested for distemper and they're negative. Okay. Somebody help me out with what's 8 times 0.24? 1.92. Q. Plus, what is 8 times 0.38? 3.0 what? Thank you. and that equals 16x. And then I actually add them, and then I divide by 16, and I'll have my number. 4.96, thank you, divided by 16, and that gives me 0.31. And what the heck did I just figure out? The total percent is 31% acid. Okay? All right, here's another problem, except this time I'm giving you nothing except I'm going to tell you a story, and you stick it into the formula and figure out the answer. All right, here's the story. My son likes his Kool-Aid really, really thick. Like, you know, the normal is, the normal recipe for Kool-Aid, he usually doubles it. So like if you have the normal amount is to add, you know, like 2 cups of water to this packet of Kool-Aid, he'll just add 1 cup of water because he likes it like super sugary, sort of like a hummingbird. Anyway, so we're gonna go with a percent Kool-Aid where 100% would be the stuff would be like just super like solid, yeah, pure powder basically. Okay, so let's say that you have 5 ounces of 85%. How much pure Kool-Aid would you have to add to make it into 90% Kool-Aid? It's currently 85%. How much pure Kool-Aid, which would by the way be 100% Kool-Aid, would you have to add to make it up from 95%? We want it, or 85%. We want it to go up to 90%. This formula will be very handy. All right, so how much did I start with? 5 ounces of 85, I think I said, right? Plus, I don't know how much to add. X times, well, it's 100% Kool-Aid. I'm going to call it 1.0. Or 1.00 for 100%. The total I'll have is 5 plus X. And it will be 90%. You multiply some stuff out, divide some stuff. At the end, when you solve it, you'll know X, which is how much pure Kool-Aid he has to add to make it just the way he likes it. All right. If you understand that, you've learned the thing for the day. And we just have a few more things that we have to learn this week. You learn how to do mixture problems today. You'll need to know that. We'll practice them again too. And then tomorrow we're going to learn a different kind of word problem that you'll have to know how to count. But this will be your favorite kind, I think, honestly. You'll be like, oh, easy one. All right. Somebody that's got their work shown nicely, what's 5 times the 0.85? See, 4.25. And this is x times 1 is x equals, and then 9, I can do that in my head. I'm distributing this out. 9 times 5 is 45, so it's 4.5 plus 0.9x. And then I just have to, well, I got x's on both sides. A lot of you get confused at this point and try to get the numbers out of there. You don't. You get the x's fixed. I got x's on both sides. Get rid of the smaller one. The smaller one's 0.9. Subtract 0.9x from both sides. And shouldn't have underlined it. Makes it look like a divide. So now those cancel. And now I have 0.01x, no, 0.1, sorry, 0.1x, 4.25, and 4.5. And then I'm going to divide by 4.25 and then divide by 0.1 and the final answer. Did I say that wrong? I'm going to get this over here. I don't know what I said before, but yes, it's subtract 4.25. from both sides, and then divide by 0.1, and what do you get? Final answer, 2.5? Negative wouldn't make sense in the context of the real world here. I think you're, because, you have negative 0.25 of something would mean we had subtracted, actually. Okay, so 2.5 ounces of pure would bring me up from 85 to 90%. All right, now it may seem hard, like that seems like too much to have to add to make this go up. You're adding half of what you had before. But when you're at an already high percent, it's hard to make it higher. It's like if you're at a really high grade going in this class. Let's say I got a 95% going in the class. Don't you have to get like almost 100% to make your grade go up at all? So you have to have a lot of that to make your grade go up a lot. You have to take a lot of tests at 100% to make your grade go up. All right. Okay, I think I've covered the mixture problem pretty much well enough. And at this point, your homework is right here. I'm deciding not to grade anything for today, but you're probably pretty much a lock that I'll grade something, maybe even 2 things tomorrow. Here you go. 1, 2, 3, 4, 5.